Question 8 now. So keep in mind for question 8, there are questions that are A only. Group A students are doing all of these. Group B students are doing the green ones and the yellow ones. So green and yellow, which is all of those. And again, we have our little reminder down the bottom here and on the next page. So let's go through each of these. So Group A students, again, what we're doing is we are solving it systematically. And we have two parts, we have two parts to this equation. So we solve the equation systematically and we show our steps. Then we go back and check our solution by substituting in our value, and we want to get our left-hand side equaling our right-hand side. So I'm going to structure it like this so you can absolutely see how this works. So first thing I'm going to do, I've got question A here, and then I'm going to have the AI and then AII. So having a look at our question here, I have a multiplication here and a subtraction here. So I deal with the subtraction first and I do the opposite operation. So I add 2 to both sides. Then I can write my next line, which is just 6f. And then 64 plus 2 gives me 66. I then, again, now I've got a multiplication, and to undo that, I do the reverse, which is division. So I'm going to divide now, and what I do to one side, I absolutely do the other. 6 and 6 are going to cancel out. I end up with f. And 66 divided by 6 gives me a value of 11. I've now actually solved it. Now to double check whether that solution is true, whether it is correct. So now I'm using f equals 11, and I'm substituting it back into our original equation. So I've got 6f minus 2 equals 64. So I've got 6f minus 2 equals 64. Let's plug it in and make sure that our left-hand side equals our right-hand side. So 6 multiplied by 11 minus 2. Let's see if it equals 64. So 66 minus 2 does indeed equal 64. So 64 equals 64. Therefore, we can say our left-hand side equals our right-hand side. And that is how we want to approach these questions. Okay, next one. Again, same system every single time. So let's keep going. First thing I have here, I have brackets, and I also have multiplication, so I'm going to do the multiplication first, and I'm going to undo that. So I undo multiplying by dividing, and what I do to one side, I do the other. I end up with a minus 8 equals 1, because I've got 3 over 3 equaling 1, and these two 3's cancel each other out, and I'm just left with the a minus 8. And again, I have a subtraction here, so I do the reverse, which is addition. And what I do to one side, I absolutely do to the other, and I end up with my value of a equaling 9. Now again, I'm going to substitute it back into my original equation. So here is what I'm substituting in. A is 9, and here is my equation, 3. A minus 8 equals 3. So let's check if that is indeed a true statement. So 3, and then in brackets, I've got 9 minus 8. So 9 minus 8. And we want to say that it equals 3. So let's double check. I've got 9 minus 8, because I do my brackets first when I'm normally doing this process. Instead of solving for, I'm evaluating. So 9 minus 8 is 1. So I end up with 3 multiplied by 1, which does indeed equal my right-hand side. So again, our left-hand side does indeed equal our right-hand side. On to the next one. Again, same process. We're using exactly the same every single time. So I have a subtraction and I have a multiplication. So I'm going to deal with my subtraction first. So I'm going to plus 8 to both sides. And here is me going through my question. And then we will double check it. So once I've done that, I end up with 2n equaling 14 plus 8 gives me 22. I then have to undo this multiply by 2. So I divide by 2 on both sides. And I end up with n equaling, so 22 on 2 gives me 11. Next thing, again, exact same, I'm going to now substitute n equals 11 into my equation, which is 2n minus 8 equals 14, and double check that the left hand side equals the right hand side. So let's double check for the left hand side. This is a slightly different way you can write it, but again, equally as valid. So 2 multiplied by 11, and then I'm taking away 8, and this equals 22 minus 8, which does indeed equal 14. So, in this one, again, our left-hand side equals our right-hand side. Okay, one down here for letter J. With this particular one, first thing I can see is I need to actually flip it because my pronumerals need to be on this side. So that's my first step, regardless of what I'm doing next. That is my first step. So I'm going to do that now. So let's rewrite it. So I've got 3q minus 3 equals 30. Now I'm going to find the value of q by solving this. So I've got a multiplication, I've got a subtraction, so I'm going to add to undo that subtraction. And again, what I do to one side, I absolutely do to the other. So then I have 3q equaling 30 plus 3 is 33. Now I have to undo this multiplication, and I do that by dividing on both sides. So let's do that. 3 on 3, 33 on 3, to give me a value of 1q, or just q. Those cancel out. I end up with just my q. And then I have 33 divided by 3 gives me 11. So again, substituting it in, making sure it all works. So q equals 11. Let's substitute it into our equation. 3q minus 3 equals 30. So for my left-hand side, I've got 3 multiplied by my value for q, which is 11. 3 multiplied by 11 minus 3. So that gives me, so 3 multiplied by 11 is 33. Minus 3 gives me 30. So therefore, my left-hand side equals my right-hand side. So it is a true solution. Okay, last couple ones for M and P. So again, let's have a look at what we have to start off with. And first thing I can see, I have an addition and I have a multiplication. I undo the addition first. So the reverse of addition is subtraction. So I minus 7 from both sides. Let's put in all of our structure. And then, so I am ending up with just 10d. 47 minus 7 gives me 40. Now I need to get the d by itself, so I need to divide by 10 to get rid of that number in front. And what I do to one side, I do to the other. So I divide by 10 on both sides. I end up with my value for d. So again, those cross out. So d equals 40 divided by 10, which equals 4. So let's double check that that is indeed a true solution to prove the left-hand side equals the right-hand side. So we have our equation here. So 10d plus 7 equals 47. And we are now going to substitute this in where that d value is. So let's do exactly that. So I've got 10 multiplied by my d value of 4 plus 7 equals 47, hopefully. So for my left-hand side, which is what I'm working with, so 10 times 4 is 40 plus 7, which equals 47. And my left-hand side then does indeed equal my right-hand side, because my right-hand side, remember, was 47 as well. Okay, last two for group A. Again, just spend a bit of time making sure that you've got the process and then keep going. Okay, first thing I can see, I don't have my pronumeral on the correct side, so I'm going to flip this equation first and foremost. So I write my equation, so 10c minus 3 equals 7. Now I can start answering my questions. So let's do just that. I have 10, apologies. I have a look at my equation. I have a subtraction and I have a multiplication. So I deal with the subtraction first. And I do the reverse operation, which is to add 3. So I end up with 10c equals 10. And again, remember these two cancel out, so that's where I got the 10c from. 7 plus 3 does equal 10. So 10c equals 10. I need to get the c by itself, so I need to divide by 10 on both sides. So I'm going to do that now. Once I do that, I end up with c equaling a value of 1. And again, let's double check that it actually makes sense with the equation. So if I have c equaling 1, and I put into the equation 10c minus 3 equals 7, let's have a look at our left-hand side. So 10c minus 3, we substitute in. So I've got 10 multiplied by 1 minus 3, so that equals 10 minus 3, which equals 7. So then, as well as the others, our left-hand side equals our right-hand side. Done. Last one for A people, and then on to B questions. So for this one, again, let's have a look at what we've got. We've got brackets and we've got a multiplication. Brackets come after the multiplication, so deal with the multiplication first. So let's do that now. And to do that, to undo it, we divide instead of multiplying. And again, what we do to one side, we do the other. So I'm just left with this, which is q plus 8 equaling 40 divided by 4 gives me 10. Okay, keep going. I now have a addition, so I need to subtract, and again, do it on both sides. And keep going, so I end up with q, because again, these cross out, so q is a value of 10 minus 8, which equals 2. Now let's substitute that back into the formula to make sure that it was indeed correct. So if q equals 2, let's make sure that the left-hand side equals the right-hand side. So let's substitute it in now. So I've got 4 on the outside, then I've got q, which is 2, plus 8. And again, this is for the left-hand side that we're now substituting in. So 4 multiplied by 2 plus 8 is 10. So 4 multiplied by 10 equals 40. So therefore our left-hand side equals our right-hand side, because 40 does indeed equal 40. And now on to B questions. So again, same exact process, you've just got a couple more questions. And again, similar process every single time. You are looking to find the solution, then you're double checking that solution as you go on. So let's set up our scaffold. First thing here, this one's quite easy. I've got a subtraction and I've got a multiplication. In terms of my BODMAS going the other way, so it's Sam Dob, I start off with my subtraction to undo that. So that's the first one I'm going to do here. So if I'm undoing a subtraction, I need to add, and I add to both sides. So that then gives me 5x, again, because these two cancel each other out. So 5x equals 41 plus 4 is 45. I now need to get my 5 away from my x, so this is multiplying. So I need to divide by 5 on both sides, so let's do that. So once I've divided by 5 on each side, I end up with x giving me a value of 9. So let's double check that value. If x is 9, let's substitute it into 5x minus 4 equals 41. And when I'm doing that, I'm going to substitute in my value for x. So I've got 5 multiplied by 9 minus 4 for my left-hand side. And let's go. So 9 times 5 is 45. Minus 4 equals 41. And 41 does indeed equal 41. So our left-hand side equals our right-hand side. Beautiful. Keep going. Next one. 5k minus 9 equals 31. So again, I start off with my subtraction and I have my multiplication next. So undo your subtraction by adding. What you do to one side, you do to the other. Write it out. So 5k equals 40. Going to pick up the speed a little bit for this one. So undo multiply by dividing. And keep going. Your value for k, so 40 minus 5 is 8. Substitute it in and keep going to make sure that your right hand side equals your left hand side. So I've got k equals 8 and my expression of 5k minus 9 equaling 31. So let's do our left hand side. Let's make that a bit prettier. So left hand side is 5 multiplied by my value for k, which was 8. And then I'm taking away 9. So 5 times 8 is 40. So 40 minus 9 is indeed 31. So therefore, again, our left-hand side equals our right-hand side. So that is a true solution. Okay, next one. I've got 1 equals 2g minus 7. So first thing I'm going to do is I'm going to flip it because I need my pronumeral to be on this side, not on this side. So let's do that first and foremost. So let's rewrite. So we've got 2g minus 7 equals 1. Let's have a look at that now. I undo my subtraction, so I plus 7 to both sides. So I end up with 2g equals 8. I then need to get my g by itself, so I divide by 2 on both sides. And once I do that, I end up with a value for g of 4. Now let's double check that. Double check that it is a real solution for this particular equation. So I've got 2g minus 7 equals 1. So let's check our left-hand side, and we're going to substitute it in. So 2 multiplied by our 4. 2 multiplied by 4. And then I'm taking away 7. That does indeed equal 8 minus 7, which equals 1. Therefore, our left-hand side does indeed equal our right-hand side. Okay, last two for these. Sorry, last three. So letter K, let's have a look what we're starting off with. I've got multiplication and I've got subtraction, so do subtraction first by adding to both sides. So we're solving the equation first, and then we are going, then we are going to be checking it as we've done with all the other ones previously. So I end up with 3z equaling to 26 plus 4 is 30. I need to undo now my 3, so I do that. So I end up with 3z over 3 is z. 30 divided by 3 is actually 10. So let's write that out, 10. And again, substitute it in, make sure your left-hand side equals your right-hand side. So z equals 10, and my equation is 3z minus 4 equals 26. So let's substitute it in for my left-hand side. So I have 3 multiplied by 10, and then I've taken away 4. So I end up with 30 minus 4, which is 26. So indeed, my left-hand side equals my right-hand side. Same value. Okay, last two. 9u plus 2. Again, I've got an addition and I've got a multiplication. Deal with your addition first by doing the reverse operation. So minus 2 on both sides, giving me 9u equals 45. Now I need to get rid of that 9, and I do that by dividing by 9. So I end up with u equaling, so 45 divided by 9. So 5, 10, 15, 20, 25, 30, 35, 40, 45. So that is our 5 times tables. So u equals 5 in this case. And again, we need to check by substituting it back in. So let's exactly do that now. So I've got u equals 5. And I've got my equation of 9u plus 2 equals 47. So let's make sure that that one actually works, same as before. So let's substitute it in and keep going. So 9 multiplied by my value for u, which was 5, plus 2, so this is my left-hand side. So 9 multiplied by 5 plus 2 equals 45 plus 2, which equals 47. So again, my left-hand side equals my right-hand side. Last one. Again, keep in mind with all of these, speed them up, make your life a bit easier. I'm just going a bit slower with these. So first thing, I have a multiplication here and I have an addition. Deal with the addition first. So I take away 10 from both sides and I end up with 8q equals 88. I then divide by my 8, which is the number in front of my q. It's the number in front of my pronumeral. And then 8q divided by 8 is just q, and then 11 divided by 8, sorry, 88 divided by 8 gives me 11. And again, let's keep going to make sure that it actually adds up. So I'm substituting q equals 11 into 10 plus 8q equals 98. So let's do our left-hand side as we have done all before. So I've got 10 plus 8 multiplied by my value for q, which is 11. And let's see what that actually equals. So I've got 10 plus 88, which equals 98. And again, that means our left-hand side equals our right-hand side. Hopping back to the other video to finish these off.